Um, okay, so we finished talking about panel modeling, and a continuation of that. As a continuation of that, I'll start with talking about productivity or productivity change, because when you are measuring productivity change, like you need to have a panel data. Okay, so that sense is a natural extension of panel modeling. Okay, and again, of course, I'll be adding inefficiency component to it. So let me start with measuring output-oriented inefficiency, or both output and input-oriented inefficiency. So if you are observing a particular form with some level of input X, like this much, that means you are observing point A, that means the output is given by this distance, and then since it's an inside point, it's not on the production frontier or production function, there is naturally a gap between what you observe and what the maximum is, or what we sometimes say, what is the potential, okay? So you have a potential which is given by the distance from here all the way to B, but you are actually getting only from here to A. So this AB is what I said output shortfall, and we mentioned that this is a measure of output oriented inefficiency. Now if you look at it this way, so going up north, and if you go down or go this way, that means if you go, then again you will be hitting the frontier. That indicates that there is overuse, depends on how you look at it. In other words, what I'm saying that what distance AC indicates how much of the inputs are overused or unnecessarily used. Okay, that means you can reduce your input use by this distance AC without reducing your output. Okay. Now again, like this slide in here says that what productivity and efficiency are often used interchangeably, but they are not exactly the same, and you will see that in a few minutes. They are closely related, but the concepts are very different. So the question would be, if a particular form A is more productive to another form B, does it necessarily mean that form A is more efficient? Okay. And you will see that, well, that is not always the case. Okay, so what do we mean by productivity? Okay, so this graph illustrates what we mean by productivity in terms of one input X. So again, like if you are thinking that you are like one input is kind of not the reality. In reality, there are more than one input. Just think in terms of X as a measure of resources. Okay. And Y is output. So again, we can talk about productivity is defined as average product. So Y over X is a measure of productivity. And this is widely used in government statistics. For example, even in the U.S., whenever we talk about productivity, pretty much everybody relates it to labor productivity. That means Y over L, where L is labor. But you know that, well, I mean, output is produced with not only labor, but some other inputs also. So we need to extend this measure of productivity, simple productivity, Y over X to something else which we call total factor productivity. Okay. So you can see from this graph what is happening. If you start with, let's suppose we're talking about two forms, A and B. So let's say, I think this is, so was there a problem if I was putting it on the desk? Anyway, it's not a problem for me, but again, this noise is irritating. Okay, so if you think in terms of two firms A and B, well, now it stops. Okay. So if you think in terms of okay. So if you have two firms A and B, so XA is the amount of resources firm A is using, and XB is the amount of resources that firm B is using. So of course B has more resources, right? Now what is happening to productivity? So look at the slopes. I mean from origin to this point. So that's the productivity for firm A, and this is indicating productivity of firm B. So which firm has more higher productivity? A or B? Okay, so remember that productivity is y over x. So for A, productivity is measured by the slope of this line. So this is average product or productivity of firm A, and this is the productivity of firm B. So which firm is more productive, A or B? B? Okay, so this is the slope. Which slope is bigger? This one or this one? A, right?
Yes, sir.
Okay, so look, I mean, when you connect this, you get a slope like this, right? And we connect this point B, you are getting a slope like this. So that slope is smaller. So again, like this production function is telling you that resources, if you have more resources, of the firm is bigger, using more X, it is not more productive. In fact, it's less productive. So this is counterintuitive, right? Sometimes we remember, I just mentioned at one point that we often say, especially in development economics, that the country is poor, meaning that productivity is low because we don't have enough resources, right? This is a common perception. But again, in terms of a graph like this, it's just saying that, well, that is not the case. So you might say that, well, the production function, the way I have drawn it in here, maybe, I mean, it's not right. But this is the production function we always use, right? Because it has certain features. And I started talking about the properties of the production function. So this is usually we write it as a concave function. Even if you change it and do it like S set, okay, still there will be a concave part at some point, okay? You cannot have a production function like this, okay? That means you cannot have a production function, let me just draw it and just to show. You cannot have a production function like this, okay? If that is the case, then it will violate, some principles of, like a production theory, okay? So if you have a production function like this, then again you have more resources, your productivity is going to be increasing. But that is not the production function that we talk about, because it would satisfy what we call diminishing returns, right? As you use more and more of an input, okay, the productivity of that input will go down, okay? It will still increase, but the rate at which it increases will go down, okay? So we cannot have a production function that is given by the deadline, okay? So again, like as I said, well, I mean, this concept that or this view that productivity is going to be higher when you have more resources, that is not always the case. Okay. So what is happening? I mean, the counterintuitive part, we can say that, well, I mean, there is nothing wrong in measuring productivity. What is happening is, if the firm is bigger, then again, like it might have a different technology. So the production function that I have in here, okay, is not necessarily the same for A and B. So maybe for firm B, which is bigger, or think in terms of a firm that is using more, R&D and that type of thing, that might have a better technology. So I'll get to that. I will have a graph to show you that aspect of it. Just mentioned it because you might be saying that, well, there is something wrong. I mean, when you look at it, when I was thinking about that, I thought that, well, there must be something wrong in the way we are looking at it. Okay, so now let's just relate profit with productivity, because at the end of the day, we are all, or every company is going after profit, right? So again, like just if I ask you a question like this, do you think that, well, if you just talk to a farmer and then you say that, well, you are very productive, do you think that the farmer will be happy? Because productivity, the way we define, is a physical measure, right? How much you get per unit of labor or per unit of fertilizer or that type of thing, right? It is not telling the farmer anything about profit, because the profit is something that they are interested in. Now the farmer will be happy if you just say that, well, you know what, your profit is bigger than your neighbors, okay? Because that is well understood. What do you mean by profit? Instead of what do you mean by productivity, because that's kind of a physical measure. And if you look at industries like computers, what is happening to productivity over time? Productivity is increasing at a very fast rate, right? Computers are becoming better and better. Now what is happening to profitability of those companies? Are they also increasing? No. I mean, if you look at data, you will see that, well, they have a very thin profit margin, because the competition is so intense. So it's not always the case that, well, if you are very productive, okay, your profit is going to be also very high. Now in order to show that, okay, what I'm going to be doing next is link profit with productivity, okay. So what is the definition of profit? Profit here is pi, this is profit. Profit is equal to, because you are, can be a student, right? Profit is the difference between revenue and cost. What is revenue? It's price of output times output, right? Because output, remember I was saying that, well, that's kind of a physical measure, right? It's not value terms, right? So again, like you define it as revenue, which is P, output price times output Y, and then we are using only one X because that will help me to draw the graph. Okay, you can have many X's. So this is W is the price of X. So if it is labor, W is the price of labor, and X is labor. So this is the cost of input X, and that's kind of the definition of profit. Okay. Now I want to draw this relationship in the same graph. And remember, in the graph, in the vertical axis you have Y, and in the horizontal axis you have X. So I have to rewrite this equation in a way that I get Y on the left hand side and X on the right hand side. So it's very simple. What you do is you divide both sides by P, and then again move this guy to the other side. So what is happening is Y is equal to pi over P plus, because I'm taking it to the other side, and then W divided by P times X. Right? So this is kind of one line of algebra. So now if you look at this, it relates Y with X. Right? So I can draw the graph. Okay. Now what sort of graph will be, or should I get? So this is again a straight line. Okay. What is this? Pi over P for this straight line. This is the intercept, right? Okay. And what is W over P? Slope. Slope. Very good. So again we get a line, it's a straight line with the intercept which is giving you profit adjusted for output price or real profit. Okay. And the slope is again like a real wage, or again a wage, if X is labor, wage divided by output price. So that is how you can interpret it. So let's just put that graph in, or that relationship in the same graph. So it looks kind of a little bit complicated, but again I will explain that. It's not complicated at all if you go through this thing. So this line in here is the production function. So this line, okay. So that's kind of the production function that I have done before. And then I have several points like x little a, x little b, and then x dot, and this. So there are 4 or 5 different values of x. Okay. So for each of these things, you can draw these lines to indicate their productivity or average productivity, right? So average productivity associated with this much of resources is what you just draw this line, and the slope of that is going to be average productivity. So again, as before, I was asking the question, what is going to be happening if you look at farm A or B using this much of X and this much of X, then you will see productivity is decreasing. So for concave production function, average productivity is going to be decreasing all through. Okay, so that means if you write it out like this, okay, so let's just say that you are doing like this, average product in here and X in there, then is going to be falling. Okay, it's always that way. So the productivity is going to be falling as X increases. Okay, that is coming from the concave shape of the production function. Okay. Okay, so that's one point that is I already shown you in terms of the graph in the previous slide. Okay, so now again, what the new thing in this graph is this. This is the relationship in terms of profit. And if I draw this line, remember this is a straight line. So these lines, again, 1, 2, 3, these lines are for this relationship with different points. So again, if I want to focus on this point and I want to ask you, what is the profit? So you draw a straight line through this point, okay? And the vertical distance is going to be indicating profit, pi over 2, okay? So now what is happening is I have drawn several lines, so from here, so this line, and at this point another line, these lines are parallel, right? And then again for X star, this one. So look what is happening to profit. That is, you pay attention to the vertical distance. So what is happening to the vertical distance as you move from XA to XB, the vertical distance is increasing, right? From here to there. So this line, second line in here, the vertical distance, which is the profit adjusted for output price, that is increasing. So as you move from this point to this point to this point, profit keeps on increasing. What happens after X star? Again, if you go to this point and draw another line through this, that will show lower profit. Okay. So what is happening in here? Profit keeps on increasing up to this point and then decreasing. So if your objective is to maximize profit, okay, how much of X are you going to be using? Okay, again, let me ask it again. Your objective is to maximize profit. From this graph, can you tell me how much of X are you going to be using? Say it again. Well, you look for points for which the vertical distance is going to be the highest, right? So do you think that this point has vertical distance the highest? No, the vertical distance is this much. Second point, vertical distance is this much. Third point, extra vertical distance is this much. And after that, it will be also coming down. So what is this? Then this X star is the point where your profit is maximized. Okay? And again, you learn it from your standard microeconomics. It's a point of tangency between the production function and the straight line given by the profit relationship. Okay, so what is the point of this graph? First, we were showing that, well, average product is decreasing, that means productivity is decreasing. But when you look at profit, okay, what is doing is profit is increasing, as you see in here, profit is increasing all the way up to X star, and then it's decreasing. So your profit is maximized at this point. Okay, so now again, if you think in terms of the implication of this, if somebody, okay, has this much of resources and his or her objective is to maximize profit, then we say that, well, the person is resource constrained, right? Because his or her profit can be increased by having more X. Now, why the person is not using more X, I mean, that's a different story. You can think in terms of credit market imperfection. You go to a bank and ask for a loan, and bank is not giving you the money. Right? So you are constrained to have only this much. Okay. If the firm is again big or has better credit worthiness, he or she might be using this much. But if the market is competitive, you don't have any credit constraint, then you'll be always using imports up to this level extra, because that's where the profit is maximized, right? So the point is that although productivity or average product is going down, profitability, I sometimes use the word profit or profitability to mean the same thing. Okay, so the profit is again not necessarily decreasing. It will increase at the beginning, and then it will reach the maximum, and then after that it will fall. Okay, so you see that looking at the vertical distance, because vertical distance, look at the graph in an equation. The vertical distance, which is the intercept, is measuring profit normalized by output price. Okay, so this graph again, as I said, looks kind of jumbled up on different things, but again it shows basically two things. One is what is happening to average product or productivity, and what is happening to profit. Okay, so again, if your objective, and that's what we always do, we will say that objective of the firm is to maximize profit, and if that is the case, then the extra should be the amount of resources to be used. Okay, so now again, if you want to study some of these things and say that in your example or in your data, the firms or farmers in Haryana, it might be credit constraint, then again you can find out that they have a opportunity to improve their profit, but they are unable to do so because they are not getting credit. And remember, one of the purpose of bank nationalization long time ago, what was it? I think in the 60s, or I forgot the date. When this first 14 banks were nationalized, one of the idea or the guideline was that just to give credit to the small farmers, the farmers who does not have a credit worthiness or collateral to give to the bank to get the credit. Okay, I think it might be still there. Some farmers are getting credit at a lower interest rate. Okay, so again the idea is, again you can think that what was the point of doing so. The point of doing so, again in terms of this, is that profit is going to be increased, otherwise they are again operating at a level for which the profit is less than optimal. Okay, so here again this slide I'm basically explaining what I just mentioned, that if your X is less than X star, then the firm could increase profit by increasing X. That means if you have more resources, your profit is going to be increasing. If firm has X that's bigger than X star, it's way too big. Okay, so then again the profit could be increased simply by reducing your X. Okay, that means instead of expanding or using more resources, you should be, if your objective is to maximize profit. But in reality, and again you guys know probably more about it, at least I think that should be taught in MBA courses, that when you look at a farm, manufacturing farm, their objective is not necessarily to maximize profit. They might have many other objectives. They look at shareholders, so again they think of the value of the farm, they look at the shareholders stake in the farm and many other things. But again when you do mathematics, okay, at least the way things are, we have to think in terms of one objective. Okay, because when you are doing calculus, you are maximizing a function with respect to your choice is again objective function is defined in terms of one thing, either maximize profit or minimize cost. You cannot say that my objective is to maximize profit and maximize shareholders thing, because they don't match. Okay, but in reality, again, things are different from what we learn in a classroom. Okay, so this simple graph illustrates some important point, uh, and that point is relating productivity with profit. Because again, I'll continue talking about those things to explain that profit is a much better measure than productivity, because productivity is a physical measure. You can be very productive, but still you might be out of business because the product price is so low that you are not able to make any profit. Okay, and I'll get to that also in terms of a graph. Now look at this graph. I just told you that productivity is decreasing as you have more resources. Now that is based on the assumption that your technology is exactly the same. So if you think in terms of two firms A and B, and the technology for firm A is given by this production function, and technology of firm B is given by this production function. That's a higher. Okay. So now again, think of both the firms having exactly the same amount of resources. Okay. So now which one is going to be more productive? Firm B. Well, this time we're right. Okay. Because again. Oh, okay, but last time we were looking at one production function. This time we are looking at two production functions, right? So then again, when I was saying that well, it's counterintuitive. Again, that was based on the fact that technology is exactly the same. And again, in our empirical modeling, we most of the time we assume that technology is exactly the same. Because if you are looking at the farmers, let's say, what type of technology are they using? Well, pretty much everybody who has a reasonable size of land, they're using tractors, right, to cultivate the land. And when it comes to when the time comes to harvest, I think they are using harvesters, right? So nowadays, again, very few people use it. So again, I told you that well, I guess not me, but everyone else also observed. I observe more because again, like I do not live in this country. So when I was going from Kolkata to the village I'm from, so I took the train and I was looking around and I saw that the farmers and those farmland in West Bengal are basically not like this. Here it is more flat. West Bengal, some part of it is flat, but most of it is not flat. So again, the use of harvester is limited. The use of tractor is also limited. Okay, but again, nonetheless, they're using it, whatever in a form. And again, the people in this country, or maybe in other countries also, in a similar situation, they are very innovative, right? So you know that well, you cannot use a tractor. So they came up with something, right? Instead of that is kind of a tractor that is run by an individual, meaning that it has a motor. It's just running so that you don't have to use a. No, I didn't do anything. No, yeah, you can take it out. And again, I'm just asking the person who's taking the weight. I mean, you can hear it, right? Okay. Yeah. Oh, okay. So technology is a big component everywhere. Right? So what I was saying that I noticed, and probably you have not noticed in here, that an individual, the farmer is, again, it's kind of a mechanical device. So instead of using bullocks or ox, I mean, he's just using it, but he is controlling it because that way he can operate in a smaller piece of land. When I saw that, I thought, oh my God, these guys are very innovative, right? Just like the first time when they have, so the tractor, they use the engine, and I think I have first seen that well, people from Punjab, they started it. So they have the engine, it's an engine of a tractor, but they remove the tail part of it, and they attach it with, what do you say? They want to carry the crop from the field. So they have a tractor, small mini tractor attached to the engine. So that's then I was watching some videos, I think from Africa or some other countries. they are doing the same thing. Okay, so I thought that one. But again, like if you talk to people in US or Europe, they will never able to understand that why are people doing that. Okay, some of our faculty, they have never been to, the underdeveloped or third world countries. They will be puzzled to see that what they are doing. But you know that what they are doing is basically the best thing, right? You have the engine and you are making the best use of the engine, right? Throughout the year. Some people carry sand, some people carry bricks, and in the village I just see that they are just blocking the road. What are they doing? Well, they are carrying sand from the river, and then they are carrying bricks, right? And they have a very, they move very slow because it's not supposed to be like a car. But that's not the point. The point is that they are loading it or overloading it, loading it on the overloading it. They will load it up to the point of breaking it. Right? So again, this is how they.
So one thing I want to say, we are not underdeveloped now.
No, I was hesitating.
We are not third world countries now.
So I was hesitating to use the word, but I had some students from Bangladesh, and they were also talking about that. So what is the definition? What do you call developing? No.
Yes, sir.
Or
Yes,
they
sir.
talk about
We are going to
second
developed countries, sir.
Okay.
On the way of developed countries, sir.
Okay. So again, in the past we'll be saying the word developed and underdeveloped, and then we change the word the developing and.
Now world is looking at India.
Yeah. But India, Bangladesh, and Bangladesh is doing in some respect better than India. Okay. So the students, I'm saying that they were saying that okay, we are in a higher level now. So I don't know. But you know what I mean. That the first world versus second world or third world and that type of thing. Okay. Yeah. Okay. Okay. So to start all over again? No, meaning that, yeah. Okay. 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 So anyway, so whenever we talk about technical change, the point of the whole discussion is not to say that by that we mean a much better technology. Okay, one person might be more innovative, okay, or he or she has a tractor and again using the engine of the tractor to do things, and of course he or she will be much better in terms of productivity compared to someone else who does not have a tractor or capacity to use that. Now, having said that, you can argue that you don't need to own a tractor, right? You can rent it. But again, the market is not perfect, right? You have a harvesting season, you need the tractor, and then you won't be able to find it because whoever has it, they're using it, right? So again, in a textbook type thing, we always say that if the market is perfect, then you can always find those type of things. Now, if the availability is not there, you can say that I am willing to pay a higher price. So in economics, everything is determined in terms of price. We always say that if the price is right, you'll get it. Okay, that's the concept. But again, we live in a different world again compared to US or Europe, and there are some cases where that type of argument does not hold. Okay, now why is that? Now this was a shocking experience to me several years ago, getting a taxi. In Kolkata, I think I have no experience in getting a taxi in Delhi. So what we learned that whatever given the fare, they are going to be taking you to the destination, right? So it was 9 o'clock in the evening. It's not late night. So I was kind of trying to hail a taxi. He stopped and then said, "Well, where do you want to go?" I just said that, "This direction." No. I just said that, "Okay, I'll pay you more." No. And then he's going home. So the question is that what we learned in economics, that given the price, okay, you will always get, right? But these people are not interested in higher fare. And that is, I thought that, well, what is happening? What is wrong in our teaching of economics? Why this person is not interested in doing it? Because their view is completely different. We are taught that given the price, everybody is maximizing the utility or that type of thing, and price is a big component. So if I pay you per person or more, then the person is willing to accept this. And this principle is so deep-rooted in US or Europe that, well, I mean, in US, people do move, not a whole lot, but especially those people who are in the very top. So think of somebody who got a Nobel Prize, okay? So Yoshimoto, for example, who is in MIT, now he had a Nobel Prize, so some other universities might be interested in having him. So think of that, that he makes X amount of dollars per year, okay? Now, someone else might be saying that, okay, I'm going to be offering you 2 times your salary, okay? So the view is that, okay, I mean, he might move, I mean, depending on what he values, but if he values, like the taxi driver, that he is not going to move from MIT no matter what the salary is, then nobody is going to be getting it. But so that's kind of a failure to the economic model that we talk about. In economics, we always say that, well, this is the right price. Now, then somebody will say that no, 2x is not enough. Offer him 10x, then he's going to move. Maybe, again, because everybody is going after money, right, to some extent. So, he might move, I mean, if his salary is increased by a factor of 10, for example, okay. So again, coming back to the point that I was talking about, that you can do some small tweak in the technology of production, and again, that was going to be indicated by a shift, and then again, shift meaning your productivity is going to be higher, and then again, your productivity is higher, you can also relate it to profit. Because if your productivity is higher, then your profit is also going to be higher. You don't need to show it in terms of another graph. It's simple. Right? So again, the only way by which the productivity can be increased is through again a technical change. We use the word technical change to indicate a shift. Okay. Now again, if you are familiar with the famous paper by Bob Solow, who got Nobel Prize in economics, that was a macro model. I mean, his conclusion at the end was that to have a steady state growth, you have to have technical change at a constant rate. If there is no technical change, there is no way by which productivity can increase. And this is again kind of very simple, but you can explain it in many different ways. His explanation was in terms of a macro model. Here we are looking at it from a micro perspective. Okay. Okay, now let's say, well, we are bringing in efficiency, since inefficiency is one component in our one component of the workshop. So let's just say that what will happen to productivity, profit, and things like that if a particular firm is inefficient. So that's obvious. So let's look at this point A, which is inefficient, right? Because the potential is to produce this at point B. If you are looking at output-oriented measure, and again, like draw a line from point A to the origin, there's going to be productivity or average product, and then again, like productivity for if the firm was fully efficient, that would be higher, because again, like the slope connecting 0 to A is less than the slope connecting 0 to B. Right? So this is obvious, right? You don't have to look at a graph. You can say, well, look, somebody is inefficient, so his or her productivity cannot be bigger than somebody who is in a more efficient, right? But again, like you can show that in the graph. Okay. So that is output-oriented measure. Now, if you are going at input-oriented measure, so you are moving from point A to C, so you are cutting down your use of your resources or inputs, then again your productivity is also going to increase. And that is also intuitive, because look, you have 10 people working and your productivity or average product is, for example, 5. Now if you get the same job done with instead of 10 is 8, then productivity has to go up, because what is productivity? Y over x, right? Y is unchanged, x is getting lower, so the whole thing is going to be higher, right? So these are kind of obvious things. So when you have inefficiency, everything is low. Your productivity is low, right? And then again, you can bring this. I don't have that graph, because you can draw the profit line to show that profit is going to be also lower, and that's also obvious, right? Because if your output is lower, your cost is same as your neighbor's, right? Then what is happening? If your output is lower, your revenue is lower, right? So your profit is going to be lower, because your cost is not lower, because you are using the same amount of X as your neighbor. Then again, but your revenue is less because your output is less, right? So this is obviously your profit is going to be lower. Okay. Okay. So now let's just think of it slightly differently. So far, my discussion was focused on comparing between two firms, for example, A and B. Right? So now think of this, instead of comparing between two firms, think of comparing one firm over time. So A and B is basically the same firm observed at point in time t, and B is the same firm observed after 1 year, so t plus 1 or some other time. So we are looking at the same firm over time. Okay, that means we want to see what is happening to productivity over time. Okay, because instead of comparing across individuals, we are now looking at the comparison over time. Okay, so it's going to be exactly the same thing. Instead of saying that well, A and B are two different firms, I'll be now changing my explanation, saying that A and B are the same firm observed at two different points in time. Okay. Now again, the purpose of doing it is just to see what is happening to productivity over time, or what we say, we use the word productivity change. Okay, so if y over x is productivity, how do I find productivity change? So productivity change, like anything, this rate of change in productivity. So how do you define rate of change? If the variable is x, how do you define a rate of change in x? No, I mean, I'm just not talking about anything, just talking about a variable x, okay? And how do you define rate of change in x? Okay, derivative of, a log derivative of x with respect to time. Or if you don't use that type of terminology, you simply say the word rate of change is change in x divided by x, right?
Slope.
Yeah, so this is, I mean, you can do rate of change is like this. You can do delta x over x is the rate of change, okay? Which is the same thing as, since it's one variable, you can write a derivative of x with respect to time. Okay, so this change is over time. That's why I'm just taking the derivative with respect to time. Okay, and we are going to be using the notation dot. So x dot, okay, means rate of change in x. Okay, so now tell me this. Okay, I can write it in the next page. Okay. So if I have a variable, okay, called productivity, which is y over x. Okay, that's productivity. I want to define something called rate of change in productivity. So how do I define it? It's not hard. I told you that one for x. What do? Instead of x, you think in terms of y over x, right? This is the new variable, right? So then again, I will be doing like this, derivative of log y over x with respect to time, right? And then again, if you go through this here, I can write it y dot minus x dot. okay? I mean, you know the derivation. So if it is a ratio, then the rate of change of the ratio is given by the rate of change in the top variable minus rate of change in the bottom variable. Okay. So again, like if it is labor productivity, so your X is labor, then the labor productivity can be defined as rate of change in output minus rate of change in labor input. Right? Okay, so let me just go back to this one. So what is happening is there are two ways to go. One is think in terms of a single input, but again, you know, this is just not practical. Although I told you that I've been in the US, in a Bureau of Labor Statistics, they talk about, they publish, you know, this type of numbers about what is happening to productivity in the US economy, and they look at labor productivity. So what is the problem? That means, you know, if you do talk about labor productivity as a measure of productivity of the economy, then you are missing something, because labor is not the only input, okay? But again, I still don't know, you know, why they have not changed it, okay? So what we do is, these are called partial factor productivity. When you say that y over x or y over, so if you have many inputs, say call it xj, and j is equal to 1 through big J. So you have that many inputs, so you can define y over xj as, we call it partial productivity, or you can use the word partial factor productivity. So what is the problem of using this thing? Because you don't need any econometrics, you need data on y and x. So if you are looking at the farmers, you know how much corn there or how much wheat. I think it's mostly wheat producing area, right? Wheat and rice. So let's say what we're talking about the wheat season. So y is in a amount of wheat that is produced, and x is let's say x1 is labor or land, x2 is labor, and x3 is fertilizer. Right? So again, if you are thinking in terms of three inputs, what are you going to get? You get factor productivity, that means productivity of labor. Let me just put also capital, because okay. You can add more if you want to. Okay. So you'll be getting 4 different measures of productivity, right? Now, is it easy to compare one farm with another farm with this type of 4 measures of productivity? Farm A may be more productive in terms of labor, okay, but less productive in terms of capital. So how you want to compare whether farm A is more productive than farm B, right? But then you are having this problem, right? You have 4 measures, right? And again, like it's very almost impossible, okay, to come up with a situation where a farm is going to be dominating another farm in terms of all the 4 measures, right? I mean, it's very likely that while you are more productive in terms of capital, but less productive in terms of labor and that type of thing. So this type of partial factor productivity is not very useful, okay, to compare between farms. So to avoid this, what we do is we define something called total factor productivity, okay, or TFP. Okay. So this is also defined as y over x. But what is x? So x is a composite measure. So you have 4 or 5 different inputs. You can define a single input by, again, defining an index. Right? So x is an index of input that comprise all the 4 inputs that is being used. So then again, like when you are looking at productivity or TFP change, so we'll be using TFP dot. Okay, so TFP dot is going to be exactly what? Y dot minus x dot, okay? And then again, what is happening is, since x is a composite measure of all the inputs, okay, what is done in the literature is like this: y dot minus sum of sj. Sometimes I use a. I think in my slides I have a and x dot j. So this rate of change in the composite input is defined as weighted average of change in individual inputs, and the weights are their shares. So what is SJA? Is WJXJ divided by C. WJ is the price of XJ, and C is the cost, total cost. Okay. So then again, this is sum of the shares is going to be equal to 1. So this is kind of a weighted average of rate of change of all the inputs. So this is kind of the measure that is used in the literature. Okay. That means again, mostly academic literature, but again in non-academic, I think pretty much the government statistics will rely mostly on labor productivity. But again, you can always change and get the measure of TFP dot, or change in total factor productivity. Now, do you need any econometrics to do this? To get, let's say, well, your interest is to see what is happening to TFP, that means TFP dot. So TFP dot is defined in this way. Do you need to do any econometrics to get TFP dot? Yes or no? No. No, right? Because what is y dot? Is rate of change in y. So y is data, and if I give you data on y, you can compute y dot simply by defining. So what is y dot? Delta y divided by y. Okay. So again, like if you are doing Excel, then again you have the column for output. You define change by taking successive differences and then divided by the total. So that would be your rate of change in y. Similarly, you define rate of change of each of the inputs, right? And then again you define the shares. So all you need is data on physical quantities of inputs, outputs, and then not necessarily the prices. You don't need to get price of each input. All you need is the cost of each input. So how much is paid to the labor instead of looking at the wage rate, how much is paid to rent your tractor, how much is paid for fertilizer. So all you need is this and then once you get this, you can define cost and therefore the share. So whatever is needed to define the shares is fine. That means you don't need to get to the individual prices. Okay. So then again, like if your objective is to measure TFP dot, then you don't need to do any econometrics. All you do is get the information on physical quantities of inputs, outputs, and then their cost share. Okay. Well, that might be good for many because when you just said, well, my objective is to look at simply what is happening to TFP over time, or a particular firm, or a particular industry, or a particular state. Remember, we were talking about different states in a country, or different countries of the world. It depends on what is your objective and what type of data you have. Okay. Now, if that is the case, then we should be ending in here, but no, we just go beyond that. So what we do is, after defining this, we just say, well, if your objective is to simply, okay, measure TFP dot, then this is the end of the story. Okay, you don't need to do anything else. But then we just say, well, no, this is not the end of the story, because we are not only interested in getting a TFP dot, or what is happening to TFP for a particular farm. By farm, I mean, again, like any entity, agricultural farm, manufacturing farm, again, in a state, in a country. We want to know how much of the TFP in a growth or TFP change is coming from different sources. So we want to decompose TFP or change in TFP to different sources. Now what we mean by sources, you will see that in a minute. That means we are not only interested in finding out what it is, but what are the sources. And by that, I mean, just to give you a glimpse of that, we are interested in knowing how much of it is coming for example, technical change. Okay, is it or how much it is coming from input use. So we often say that, well, can productivity be input driven? What is the meaning of that? That is, by using more inputs, can your productivity be increased? We have seen that, well, that is not possible in a simple illustration in terms of the graph. Now we want to show that, well, what is going to be happening when you have multiple or many inputs, right? So we want to know those type of things. That means we want to decompose productivity change into various components, and you will see what those components are. Okay, so that requires a little bit of math, but again, like, that's not econometrics, and I think you should not be afraid of math, at least. I mean, being I still believe that, well, you are much stronger than my undergraduate students in terms of doing the math. No, math, simple math. I mean, you are talking about high school math. I mean, derivative and that type of thing. I mean, so this is my first role. I always say that in teaching econometrics, that if you are scared about math, then again, this is not the class for you, because the whole course is, again, doing math in some form or other. Okay, and math meaning is just algebra, not arithmetic, because I don't, in the class I don't do numbers, right? So the numbers are done in a lab type situation. So we usually have discussion classes taught by teaching assistants, and then they do those type of things. I mean, some professors do that, but again, I don't switch between lectures and like a computer showing something. That might be more effective, but anyway, we just try to do it in differently, like what we are doing in here. I'm just lecturing, and then you'll just see some illustration using standard. So what is happening is that in order to figure out different component of TFP change, we have to estimate either a production function or a cost function. I have not defined a cost function, which I will do later on today. So let's just start with the production function. So just writing, this is, you have seen that before, but let me repeat it. So we have two subscript I and T. Okay, so this is panel, because again, to talk about productivity change, you have to have time, right? And again, you are talking about productivity change for each industry, right? Or each state. So you have to have states, right? So you have to have a panel to talk about productivity change. Okay, you cannot have cross section to do that. So you have XIT, you have different inputs. So this is a vector of inputs, not 1x, and then I put T in here. So why I putting T? T is the time trend. So if you have 10 years of data, you can think in terms of T is equal to 1, 2, 3, 4, all the way to 10. So this is kind of scaling it. So if the data is from, let's say, 2010 to 2020, so you have 10 or 11 years of data, you just say, well, if the year is 2010, then T is equal to 1. So you just define a new variable, T, which starts from 1 and then goes all the way to whatever number it is. Right? So the reason we're putting T in here is that, well, we are interested in the shift. Okay? And the shift can be neutral or non-neutral. You can put T outside this one and write it. But anyway, we want to put T in there. So the idea is that, well, even though inputs are held constant, you're not changing it, your output might change over time because of various things. You are learning things over time. So that might lead to a shift in the function. Okay. So you are not using any more land or labor or capital. As you see that, well, you see what your neighbor is doing, and if you think that, well, he or she is smarter and doing something very innovative, so you might follow that. So that's not factoring into any of the standard inputs. Okay. Okay. So and then again, U is inefficiency. So this is output oriented inefficiency. Okay. Um, so again, now again we are using this definition of TFP dot, which is y dot minus this. I just told you that that's kind of the standard definition that is used in the literature. Okay, so we'll be using this one to find out TFP dot. Okay, and then what you do is you just take a derivative of this, or what we call total derivative or total differential of that with respect to time. Okay, so what you do is you just take a log of this. Okay, so this means log of yit is equal to log of f and minus uit, and then you take a derivative of this. Okay, total differential, that means not partial. So this, and then again you do the derivative on the other side. Okay, and then what you do is that I can do this thing, but there is no point in going through the steps. So if you take a derivative of this and use the definition of TFP dot like this, remember y dot, so this is y dot. Okay, so there will be an expression coming from the right hand side, which I'm not writing, and then so this y dot you replace by that, and then you subtract this, go through a few lines of algebra, and you will find an expression that looks like this. So let's just focus on the last line in here. So TFP dot, okay, has these components. So what are these things? RTS is returns to scale. I define returns to scale in this way. That means, the input elasticity is sum of that. Okay, so that is returns to scale. And then again, I define lambda j somewhere in here. Okay, it's input elasticity divided by returns to scale. What is TEC? It's technical change. It's the shift. And what is TEC? That means change in efficiency. So what is the definition of TEC? Is minus du dt. So basically what is efficiency? E to the power minus u. So if you take a log of that and differentiate it, so this is equal to TE. So technical efficiency change is going to be derivative of this, a log derivative of that. So that's going to be minus du dt. Okay, so you have a component that is coming from returns to scale, and a component coming from technical change, a component coming from technical efficiency change, and then again this is kind of a last part which is coming from input misallocation, whether you are using the inputs to minimize cost or maximize profit. So that one again I will be talking about this separately. What do you mean by not using the inputs efficiently? Meaning that we know that if you are maximizing profit, the inputs are to be used in a particular way. Remember that rule is this: the marginal product or value of the marginal product has to be equal to the cost, right? And that's very simple. I mean, everybody knows that. Okay, again, to give you an example, a few years ago I was in the village, and then I was kind of walking around, and I saw there's some fields with the tomatoes, and they're not picking them up. It's just rotting on the field. So I thought that, well, what is going on? So I came back home, meaning that well from the field, and I asked them, what is going on? Why are you not picking? And you know what the answer that I got? What is the answer? Why are they not picking up the tomatoes?
Cost of transportation is higher than
Yeah, so see that, well, this is the rule that we teach to our students. And these guys are illiterate. They don't know how to read or write, but they follow the economics, right? They told me that, well, look, the cost of picking them up, and then, that's basically your cost. So this is the labor cost, right? So let's call it W. And what is the other side? That means how much you get by selling those tomatoes. Let's say, well, you are using one particular person for 1 hour, and you have to pay, let's say, 50 rupees. And then again, how much do you get? Let's say, he picks up tomatoes that is 2 kilos. And then he said, the tomatoes at that point in time, he said, it says 2 rupees per kilo. So then this is, well, it's not picking those tomatoes. So again, so they are following the rule. That means the rule is that it has to be at least equal. So the value of the marginal product, right? That means how much do you get by selling those products has to be at least equal to how much you are paying for the inputs, in this case labor. So if you are paying, I mean, you don't have to be a PhD economist or hold a degree in economics to understand that. So if you are not doing it for some reason, then we just said, well, inputs are not allocated efficiently, okay? And there might be many reasons for doing that, okay? So again, again you have this component which is picking up all those things. That means you have more than one input. So basically, you may have labor that is used efficiently, but capital is overused, right, or underused. You might have a tractor, but you're sitting in there and you are using it only in the days when you are meaning that was in the early stages. Okay, or you have a harvester that you are using only during the harvesting season, unless you are innovative and using the engine for some other things. Okay. So anyway, so these are different components, and then again, you can get it from the data, but to get these things, able to get these parts. Okay. So again, you are so this is going to be TFP change is going to be decomposed into a scale component. We just say that returns to scale. So if returns to scale is bigger than 1, this is a positive number, so that will be contributing positively. If technical change is shifting upward, that is going to be contributing positively. If efficiency change, you are getting smarter over time, that is going to be contributing positively. And if you are misallocating, then it's going to be contributing negatively, right? So, I mean, we know what it will be, but the whole idea is quantifying, right? So how much of it is, I mean, again, this is specific to individual. So you can just look at, if you are looking at data for individual companies, you can just see, well, which one has, again, a bigger share. That means you can do a comparison. Or you can just do a graph just to show what is happening to technical change for all the firms, okay? So the idea in here is not only measure TFP dot, but figure out different components of those, okay? Now I told you that, again, this is a physical measure, okay? Because we are looking at TFP dot, which is Y over X dot, okay? What is happening to productivity over time. It is not telling you anything about profit. So this is also a very kind of not tricky question. When we write papers, still now when I write a paper, or as just a student or a co-author asks me that we are getting TFP change that's negative, that's not making sense. So I just said, well, yeah, but what is the intuition of TFP change being positive? Just like if you think in terms of one input, then you get the idea that what is happening to productivity. So then again, I just said, well, no, I mean, there is not a very good intuition about whether TFP change should be positive or negative. So what we need to do is, and again, I'll be doing it after the break. So we want to get from TFP dot to profit, because I told you that profit is, it's much better to explain what is happening to profit to any individual. But if you try to explain what is happening to TFP change to somebody who does not know all those things, you will have a very hard time. But if you say that, well, I'm going to be talking about profit change, then it's going to be a lot easier. And you can just explain to a farmer that your profit change is positive, so you are doing much better than your neighbors, and that type of thing. Okay, so I'll get to that after the break, because I think there will be a tea break, and I will try to follow the time, because otherwise there will be no tea, or tea is going to be cold. Okay.
Thank you, sir, for your lecture. It's a time for tea break. Please join. We will continue after tea break.
कहाँ सपोज होता है ये लोकेश का पता नहीं वो लोकेश से जाना
Okay, so let me start and then I think we were talking about productivity decomposition and we finished showing the different components. So now again, like for easy interpretation, I told you that it's better to think in terms of profit. So if you look at this, the TFT change for a firm is positive. If that is the case, it's not clear whether profitability is or profit is increasing over time or not. So it's better to think in terms of what is happening to profit, whether profit is increasing because of TFT change being positive. Okay, so the question is, how do you define profit change? Okay, so if you look at the way I did it before, let me just show you something. Okay, so if you define profit change, you will be thinking in terms of something like this, pi dot, right? So pi dot is again like a change in profit divided by profit, right? The percentage change or just simply change. Okay, so there is a problem in here. Look at this. So if for a firm delta pi is positive and pi is positive, then the ratio is pi dot is positive, right? So the firm is earning more profit and it has a positive profit, then profit change is positive, right? Okay. Now think in terms of another firm like this. For that firm, change in profit is negative and it starts with a negative profit. What would be the ratio? It is also positive, right? So the question is that, well, if you look at simply pi dot, you are not able to distinguish between the two scenarios where one is making positive profit and the profit is also increasing, the other one is going down. It has a negative profit and the negative profit keeps on increasing. So to avoid that type of scenario, okay, instead of using pi dot, we just express profit as a percentage of cost. Okay, so to measure profitability change, okay, we'll be using this. So this is like delta pi, and then again, instead of dividing by pi, we are dividing by c. So we just say the word change in profit as a percentage of total cost. Now this will never have the situation that I was talking about in here, because cost is always positive, right? And if change in profit is positive, then we just say the word profitability. We use the word profitability to mean profit as a percentage of cost. So that is positive. If a firm is earning negative profit, then again your this measure is going to be negative, right? So we want to have a situation that we encountered in using pi dot. Okay. So to measure what is happening to profitability, we define not profit percentage change in profit, but change in profit as a percentage of total cost. Okay. So then again, you go through this the same exercise. Okay. So pi is defined as py minus wx, and when you do the math in here, you will be able to get this part and this part. Okay. So in the end, if you go through a few more lines of algebra, you will be able to see that this profitability change is depending on TFP change that we described before. Then there are basically two extra components. Here it shows three, but essentially there are two. One is what is happening to price, and the other one is what is happening to input prices. Now, this is a financial measure, right? So the question is, to increase profitability or to find out what is happening to profit, you need to know what is happening to your price. So I gave you the example of in the computer industry. Okay, what is happening to the computer over time? What is happening to the price of computers? Increasing or decreasing? Decreasing, right? If you adjust for quality, then the decrease is really fast. Okay, computers are getting better and price is also going down. But again, if you think in terms of quality adjusted, it is going to be a lot faster. So this P or P dot is negative, right? So if P dot is negative, what is happening? Then you are given everything else, this is going to be also going down, right? So I told you that a lot of firms like computer industry, they are not making profit because of the fact that price change is negative. Price is not increasing over time, it is going down. So this is contributing negatively to this. And if that happens, I told you that even though that TFP change is positive, remember that TFP change is positive, but this is dragging things down. That means you cannot survive if this is negative and much stronger than your positive TFP. So there is no reason to jump when you say that, well, my TFP change is positive. Okay, you might still be out of business, especially because of the fact that your output price is going down. And then the other component is here. This is what is happening to input prices. See, this is the same thing. You know, if labor is getting more and more costly, that means W dot L for labor is positive, right? And you have a negative sign in front. So this is going to be contributing negatively. So these two additional components, right? This has been already taken into account in here, but again, you can do some extra lines to bring this part Y dot inside TFP. So the point is that in a profitability change, we are taking into account these two things: what is happening to output price and what is happening to input prices. Okay, if they go the opposite way, meaning that one, if price of output is going down, then that would be affecting negatively, and then if price of inputs are increasing, that would also go against profitability change. Okay, so these are again very intuitive. What I'm doing in here is give you a mathematical expression so that when you compute different components, you can figure out what is the magnitude of those things. But again, you can loosely describe people that, well, what is profitability change? Okay, what is happening to your productivity and what is happening to the prices. So this is kind of simple to explain. You can instead of going through this route, you can simply write this as the ratio of revenue over cost, and again, you can just see that, well, that is affected by two things: what is happening to the prices as well as what is happening to productivity, right? So if you have only one X, it's very easy to explain it to anybody. I mean, even undergraduate people in terms of what is happening to profit. Right? So again, you see that, well, here your life is a lot easier in explaining people what is happening to profitability, because that is kind of a measure of physical measure of productivity change as well as the financial measure coming from change in input prices that is given in here and change in output prices. Since there are more than one input prices, so this is kind of weighted average of a change in input prices weighted by their shares. The weights are always positive. So if this is positive, then this whole thing is going to be positive, right? So again, there is no counterintuitive result in there saying that, well, weights can be negative. No, weights are always positive. So if price of a particular input is going up, that is affecting negatively to your profit, right? And the other thing is that, look, TFP change, I showed you that TFP change requires econometric estimation, okay? Because if you are interested in the components, right? This additional components that you get in here, they are coming from the data. There is no econometric component in there. What is R? R is revenue, C is cost. Again, you can get those from the data. And P dot is price, because you have to have price information. So this is coming from data, and this is also coming from data. Right? So the two additional components that we are adding, okay, it does not require any more estimation. All you do is that you estimate the production function, get the TFP dot components, and then again add these two things to get this profitability change. Okay, so again, this profitability change does not require any extra work in terms of estimation. The extra work is just computation. So again, you need information on prices. That is kind of the additional thing. Whereas since this is a physical measure, okay, you don't need prices. Okay, so of course, in order to get this profitability, you have to have some idea about what is happening to input and output prices. You cannot talk about profit without knowing what is happening to the prices. Okay. Okay. So what is happening is I started with a production function that looks like this. So again, even though it's a panel model, what I have done is that I have added only time trend in here, okay, and then again only UIT. So there is no other things that I was talking about in the last session. Last session meaning yesterday, when I was introducing panel model. In a panel model, we were talking about introducing heterogeneity, okay, ms alpha I, and then again in the last part, the 4-component model, we are talking about decomposing inefficiency into persistent or time varying and time invariant component. So you can do those things also. That means all you do is that you can estimate it using different specification of inefficiency, different specification of F. Now one thing is that econometrically the results will change. But if something is time invariant, so if you have alpha I, what is the change in alpha I? Here, right? Change in alpha I over time, because this is all over time, change in with respect to time, so it's not affecting your TFP change. Okay, so mathematically it's not affecting, but econometrically it will affect, because adding, I showed you this in terms of those graphs, right? That is adding alpha I and not adding will make a big difference. If the true model has individual specific intercept and you don't encode it, you might be getting a completely different result. But mathematically, if you don't get to the econometrics part, you just mathematically, including alpha I, this heterogeneity, does it change your TFP dot? The answer is no, because TFP dot is again the rate of change, and anything that is not changing over time will have no impact on your TFP measure. Okay. So then two things. That means if you include heterogeneity in your F by using alpha I in there, that won't have any effect on TFP change. And again, for inefficiency, if you decompose into two parts, one is persistent, it's not changing over time, the other one is changing over time. Again, when you look at change in efficiency, that persistent part falls out, because there is no change in there, because by definition it's persistent or time invariant. So again, when you look at the rate of change over time, it's not going to be affected. So again, like one might come to the conclusion, then what's the point of using persistent inefficiency and also heterogeneity? Because if it does not affect TFP, so the case is that yeah, it does not affect TFP, but econometrically, estimating the model with or without heterogeneity is going to be different. And that's the reason why I'm referring back to the graphs. Remember, I had 2 or 3 different graphs showing what is happening, what could happen to the estimation of the production function or any function if you do not include heterogeneity. But in the true model, there is heterogeneity. Right? So again, if somebody says that, well, okay, I mean, I don't want to encode it because it's not going to be affecting TFP dot, your response would be that no, that's not valid, because the thing is that including heterogeneity will affect your estimates, right? And your estimates get into the definition of technical change, a technical efficiency change, returns to scale and everything. So all those components are going to be affected based on whether you include heterogeneity or not. So again, looking at it from mathematical point of view is not giving you the entire picture, right? Because it gets rid of this heterogeneity or fixed effect component of it. But that is very important when you estimate the model. Okay. So that is one comment that is useful. Now let me just see whether I have anything important. Again, these are the things I already mentioned. Okay, so the other thing is, again, you can complicate the model by using determinants of inefficiency. So when you talk about efficiency change, what is causing efficiency to change over time? Well, that might be because of the fact that the Z variables are changing over time. That's why inefficiency is changing. Because remember, I just said about U for inefficiency is a function of Z. and if Z is changing in I and T dimension, then when you look at this, du dt, that's going to change because the Z variable is changing over time. Okay. So then again, like this is going to be giving you one extra piece of information that your change in efficiency is caused by change in the Z variable or variables. If you have many such variables, again, you can decompose. See that was the decomposition keeps on getting bigger and bigger. If you have different Z variable, then you said, well, how much of the inefficiency change is coming from Z1, coming from Z2, coming from Z3, and things like that. Okay. Now these are all important things because when you do any kind of any application or applied work, right, you need to focus on those things because these are going to be policy variables. That's why the government is using some measure or used some measure 5 years ago. You want to find out the effectiveness of that in terms of productivity or profitability. So then again, you can just say, well, do you think that well, that is increasing efficiency of the farmers or efficiency of the manufacturing companies because it's designed to improve the quality of farming or quality of manufacturing. In farming, all sorts of things happen. Sometimes they say that well, okay, they cannot use certain types of fertilizer, but again, you don't know whether they're using it or not. But anyway, so let's say that you believe that farmers are following the direction that well, if something is not supposed to be used, they don't use it. Okay, then you want to see what is the impact of that on productivity. Is it productivity is increasing or decreasing? If anything can happen, some farmers are not following those. Again, I have seen in the village, these are kind of, I have seen those things. They're not supposed to use some of those pesticides. Okay, that means you just spray it on the plants or and then I just noticed that it is written that you cannot dilute it into water. That's dangerous. Okay, so what I saw that again this guy was doing it. He has a kind of bucket type thing. So it's just the one that you used to spray, right? And he put those powders, right, in the water and then diluting it. And I just said, well, why are you doing that? And he said, well, this is very effective. It kills everything. Then I said, well, do you think that, well, we are also getting killed? So that when I saw that, and then I came back home, meaning that, well, it's basically the home is in here and the fields are just across the house. So then I just said, well, from now on, so long as I'm in here, okay, you need to wash those vegetables thoroughly because they are just spraying it on cauliflower and then again like eggplant and many other things, and then they are not very careful in washing those things. And I said, well, these are dangerous. It's written that, but again, like they are either not reading it or they are just not paying any attention to those type of things because they say, well, I'm not eating it and I'm just selling it in the market, and the type of philosophy that we have in these countries. I'm just not using the word other countries, but if it is US or other thing, they will never do these things. And what is the reason? Why in the US or Europe they cannot do this type of thing?
Strict policies.
Not only that, there is a policy, but again here also there is a policy. The question is that well, they are not implementing it. But in the US, whenever you go to the market or buy fruits or vegetables or meat, okay, there is a code, right? And it basically tells that well, from where it is coming. So you know that well, occasionally you read in the newspaper that there is some disease coming out of this particular type of things, like for eating the salad, that means this, and again you got uncooked, right? So they can trace the farm from where this is harvested. So they go all the way to the particular field, okay, from where this thing is coming. So lettuce, right? So lettuce we eat, here I don't see people eating lettuce, but you are eating carrots and cucumber, the same thing. In cucumber at least you are peeling it. Yeah. So carrots you are peeling it. But for lettuce, it just leaves, right? So you just eat it as it is. and it's kind of dangerous. So they can trace it. Right? So meat, the same thing. You cannot escape and say, well, no, I mean, I don't know how you got infected. And then you can just say, well, okay, I use this meat that is coming from this store, and the store can trace out from which farm where this meat was coming, and so there is no escape, right? So that's kind of the difference. Right? No, I mean, I'm pretty much done, so because this is kind of, so again, what is happening is that we can find out what is the effect of, no, that's fine, I mean, we don't need to show because there is nothing in the slide that I'm talking about. Okay. So again, the point is that we want to find out, or unless he wants to, the video that he's taking, whether he wants to focus on the screen. But anyway, that's only for a few minutes. So again, the point is that, well, we want to find out the effect of this type of policy on productivity. But again, like if there is a large scale kind of cheating means on the part of some farmers, they are not following the direction. Okay, so I was talking to Professor Ramphul, who was showing me, he took me in the evening to some of the fields. It was dark, but again, he was saying that they claim that these are organic, but he said they're not organic because everybody is using chemical fertilizer. So in the level, and that's basically the distrust I have also in the US, but it's kind of a different thing. My wife would always say that, okay, let's buy these things. So she will always buy those things. I don't go to the store to buy groceries. But then again, she will be mad if I just say, well, that's Dayton, but you don't know what is the truth because of my, I grew up in a village and I see those type of thing, and people might just say that, well, they write it out, they're saying that, well, this is organic, but nothing is organic. So that's what Professor Ramphul was saying, that they will just say that this is organic, but in reality they're not organic. Everybody is using, so it's not like in the US or Europe. If you go to Finland, I mean, they are so strict in terms of leveling those things that if they find out you just mislevel it, you will be completely out, meaning you won't be allowed to produce anything. Okay. But that type of strict measure is not available in the US also because it's so big. Finland is such a small country. They can control those type of things. Okay. So again, at some of those things. What is the effect of a particular government policy on the TFP change or profitability change? Are the farmers getting better? I mean, their profitability is increasing over time because of the policy, or just going the other way down. Okay. So then again, I don't know. I'm just talking about it, but again, the government won't be listening to you. But at least you can just say, well, the government is doing it. And then again, this is counterproductive. Okay, I mean, as an academician, again, you cannot force the government to do it. So, I think last year we did a study on Indian banking, and you know that Indian banking, they are kind of deregulating, right? So they are merging some of the banks with others. So the question that I was trying to address, and I have a co-author who worked for Reserve Bank, Oviman Das, now he's in Ahmedabad, IIM. So we did a study, we just said whether this type of policy was based on efficiency or ad hoc. That is, you merge the inefficient bank with an efficient bank so that again their efficiency can be increased. And then we found that, well, this is completely ad hoc. But the government was saying that, well, they are doing it to improve efficiency of the banks. So they use the word efficiency or misuse the word efficiency without giving a proper definition of it. What do they mean by increasing the efficiency? So again, if you think in terms of efficiency, the way we define it in terms of yield, then again like, you will be able to see, because we can find out, we can estimate the efficiency of each bank at each point in time, right? So then again, like after demerger, okay, we can find out what is happening to the efficiency of the merged entity. Okay, we need some years of data, and then compare it with the efficiency of these two individual banks that were merged, and you see what is happening after merger. So that was, I mean, some people like it because I don't have any interest in that one. They cannot catch me saying that, okay, you said something that goes against the government. I don't care. First thing is that I'm an academician and I don't live in the US. Anyway, they cannot go after you. But the point is that, well, very few people have the guts to say something upfront that, well, this is nonsense. The government policy that they are telling people that, well, we are doing it, it does not, it's not based on data. There is no support for that. Okay. So anyway, you can do similar type of thing for agriculture or for manufacturing industries. All you have to do is look for some policy, and things are changing kind of every year, right? Something is happening somewhere, so you need to keep your eyes open. Okay, so I'll just stop in here, and then again we'll start after lunch. All right?
Thank you, sir, for that insightful and thought-provoking session. Now I would like to invite our next expert, Dr. Joginder Kumar. He will deliver the lecture. So, thank you so much, sir, for your expertise and deepen our understanding. And I believe that our students are also learning so much things. Right or not?
Yes, ma'am.
Okay. Thank you so much for your enthusiastic and your enthusiasm response. Yeah. So I now welcome our next expert. Please, sir.